Today, I want to explain meaning of differentiation. Differentiation is a process in calculus used to determine the rate at which a quantity changes. In simple words, it tells us how fast something is increasing or decreasing at any point. Differentiation gives the derivative which represents the slope of a curve at a point. After that, the instantaneous rate of change and last how one variable changes in relation to another. Example, if y equals to x power 2, then dy dx equals to 2x, which tells us how fast y changes with respect to x. There have 7 techniques of differentiation. First, power rules. Power rules is d over dx, x power n equals to nx power n minus. Second, product rules is d per d over dx, uv equals to u prime v plus uv prime. Have quotient rules. Quotient rules is d over dx, u over v equals to u prime v minus uv prime over v2. After that, we have chain rule. Used to composite function is dy dx equals to dy over du times du over dx. On the other hand, trigonometric differentiation. The derivative of sin, cos, tan. Example, d over dx, sin x equals to cos x. After that, implicit differentiation used when y cannot be isolated easy. And lastly, logarithm differentiation, useful for function with variables in the base and exponent.
For question 2, we have to find dy dx for the following function. A, y equal to x to the power of 2 e to the power of sine 3x. We have to use the product rule, which is y equal uv prime plus du prime. Next, we have to differentiate the each part. As we know, u equal to 2x to the power of 2. So the differentiate of u, we got u prime equal to 4x, v e to the power of sine x. If we differentiate, we get v prime 3 to the power of cos 3x. So next, we have to substitute everything into the product rule. 2x to the power of 2 bracket 3 cos to the power of 3x plus e to the power of sine 3x bracket with 4x. So we get cx to the power of 2 cos 3x plus 4x e to the power of sin 3x.
For question number 5, we have y over 3x to the power of 2 minus 1 over sin x. As we know, u equal to 3x to the power of 2 minus 1. So the u prime, we got 6x. In the equation, v equal to sin x, so the v prime is cos x. Then the function is ratio of two terms, so we will use quotient rules. In this machine, we have to use the formula dy dx equal to v prime minus uv prime over v2. So we got the sin s times cs minus 3s power of 2 minus 1 times cos s over sin s to the power of 3. For the final answer, we got 6x sin s minus 3x to the power of 2 minus 1 minus 1 cos x over sin s to the power of 2.
For question 3, given x square e for x plus y minus sine square 3x minus in y square minus 0. Find dy dx using implicit differentiation. For step 1, we have to differentiate each term with respect to x. X square e for x plus y we got 2x e for x plus y square e for x plus y. So we got 4 plus y prime. For negative sine 3x, we got negative 16 3x cos 3x. For negative in y, we got negative 2 per y prime. Negative 2 per y prime. For step 2, we have to combine derivative and set to 0. 2x in 4x plus y plus x square e for x plus y plus 6 sine 3x cos divided by x square e for x plus y minus 2 per y. For the last step, which is step 3, we have to solve for dy dx. So the final answer we got is negative 2xe 4x plus y negative 4x e 4x plus y 6 sine 3x divide x square e for x plus 2 per y.
For the question number 4, use linear approximation to estimate the value of cube root 63.99 plus 1 over square root 63.99 correct to 3 decimal places. Step 1 is let f(x) equal to cube square root x plus 1 over square root x. Step 2 is we need to use differential method. So f prime x equal to 1 over cube root x plus 1 over square root x. Step 3 is we need to use linear approximations and differentials method. So fx0 plus sx, and then we move to the fx0 plus f prime x0 sx. From 63.99 to the 64 because nearest number. So x0 equal to 64, sx equal to 0.01 because 64 minus 63.99. Step 4 is cube root 63.99 plus 1 over square root 63.99, and then f open bracket 64 close bracket plus f prime 64 sx. And then last step is solve all the problem until we get final answer, which is 4.125.